Welcome to the Chemistry Behind Cinnamon Rolls by Lilly, Almeida. The first step to making cinnamon rolls is to heat up 1 cup of milk. Instant yeast lies dormant until it is proofed in a liquid between the temperature of 105 to 115 degrees Fahrenheit. I added 2.5 teaspoons of instant yeast and let it rest for 4 minutes. After 4 minutes, the yeast became frothy to display that it has been activated. Instant yeast feeds off of the sugar and the flour within my mixture to release carbon dioxide, causing the dough to rise. The next step was to add in 2 room temperature eggs, 1/3 cup of salted butter, and 1/2 cup of granulated sugar. As you can see, while I was cracking the eggs, a piece of the eggshell fell into my mixture. A fun fact is that the best way to remove an eggshell is to use the remainder of the shell because its sharp edges help cut through the egg white. Eggs play a crucial role in the chemistry of baking because they play a part in the leavening process. This means that eggs contribute to the rising and texture of dough. Eggs contain proteins that help create structure in dough. When these proteins are heated, they form a network, trapping air in the dough. These air bubbles expand, causing the dough to rise. Here, I am mixing my mixture together, first starting with a whisk, then going in with an electric mixer. The next step to making dough is to add the flour, one of the most important ingredients. I added 4.5 cups of bread flour, occasionally going in with an extra 1/2 cup, if needed. Flour is used for structure and quick breads. This substance allows the mixture to produce gluten, making the bread lighter and fluffier when going through the baking process. When adding in my flour and other ingredients, I used a spoon and level method to ensure accuracy. After I covered my dough and set it aside to rise, I started on making the filling. This consisted of 1/2 cup of salted butter, 1 cup of packed brown sugar, and 2 tablespoons of cinnamon. While I make the filling, I will describe the chemistry in making cinnamon rolls. The reactants include sugar, which is glucose, which has 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms, which combines with 6 O2 oxygen. They split up where the atoms come together in new forms. The sugar splits up into carbon dioxide and water, which are our products. When you mix sugar and yeast dissolved in water, forming bubbles of carbon dioxide. The covalent bonds that hold together the sugar and oxygen have split up and formed our products of carbon dioxide and water. We also add energy, which is the oven, and the sugar splits up, and in the process, energy is released, which is an exothermic reaction. One of the most important ingredients in making the cinnamon rolls are eggs, which contains lectin found in the egg yolks. It serves as an emulsifier, stabilizing the ingredients within the mixture. I used a glass pan to bake my cinnamon rolls because glass retains heat better. The glass pan is non-reactive, meaning that the end product won't have any flavor from the pan on it, as opposed to a metal pan, which can leave the cinnamon rolls with a metal taste left over from the pan. Since this is baking at a temperature above 250 degrees, the proteins and sugars are broken down, which causes Maillard, browning within the rolls. This method enhances the taste, smell, and overall looks of my rolls, making them a brown color. Here you can see me making the frosting, which consists of 6 ounces of cream cheese, 1/3 cup of salted butter, 2 cups of powdered sugar, 1/2 tablespoon of vanilla extract, and about 1 tablespoon of heavy cream. Here you can see caramelization occurring. Caramelization happens when the cinnamon buns reach around 350 degrees or higher. The sugar releases water, creating the steam. The cinnamon buns took about 30 minutes to bake and overall were delicious. I hope you enjoyed cooking chemistry with Lilly.